Somebody give me a thumbs up. All right, welcome. This is the design evolution of elm-css and elm-test. I'm Richard Feldman. So I want to start off by talking about elm-css. So this is a project where the original idea was actually pretty small. It came out of sort of a pain point I've had many times in my career, which is basically CSS style sheets are kind of hard to maintain. So you describe all these classes, you add all these styles, and then over time, you get this big collection of them, and you're like, okay, so I think I deleted everything that uses like this menu class, but is it safe to delete it? I don't know. What if I'm using it in other places and I forgot? Like menu, probably if I grep for that, it's going to show up a lot of times in my project. It's even worse if it's something like button. Like if I have a class called button, I'm like, oh, how many search results do I have for button in all of my pages? How actually safe is it to delete this style? Probably not very. And so I was kind of asking this question, like, is there some way I could do better? Like, what if we could use union types to represent class names? And that way, if I wanted to delete one of these union type constructors, and I was writing my style sheets in Elm, if that was still being used somewhere in my view code, I would get a type mismatch, and it would no longer compile. So then I could finally safely delete class names, which is a real technological accomplishment somehow. And so this was the idea. This was kind of all I wanted to do. And so I thought about this, and I was like, I think that should work. There's no reason it couldn't work. I'd just write a DSL for stuff in Elm and write like a two-string implementation that takes this DSL represented as a union type, the structure of the style sheet, and then spits out a string. I think that could work. So then I started thinking about it. I kind of got this slightly bigger idea, which was like, hey, if I could do that, what if like I could just type the entire CSS spec? That should work, right? It's not that big, is it? It's big. But this is kind of one of those things where it's like, okay, so I started off, I wanted to solve this pain point, and I started thinking like, well, how would I go about solving this pain point, kind of taking one step at a time. And then before I knew it, I sort of had this like really big, ambitious project on my hand, which for me works out pretty well, because I really like big, ambitious projects. So this led me to this sort of like more distilled design goal, which was basically, okay, how can I make a CSS preprocessor? The original design was just to be a preprocessor, where you can share code between views and typed style sheets. So the idea was sort of sharing code so I can, if I delete one of these class names that I've represented as a union type, I can actually be confident that it really was safe to delete. And I can have typed style sheets so that I could be sure that if I was compiling a style sheet, they would actually generate valid CSS. So this was my sort of distilled design goal after thinking about this a little bit. At first I started, like many people do, using debug.crash, which I'm just going to leave this on the slide with no context because then it just seems like I'm endorsing debug.crash. Maybe I should have thought this through better. Specifically using debug.crash for API prototyping. So what I mean is basically the question I wanted to answer was like, do these types work out? Can I actually make this API and do the pieces fit together the way they do in my head? So the way I do this is I'd sort of write out the type signature and then write an implementation that's just like debug.crash. I promise this works. And just kind of assume that later on I'll come up with an implementation that works. But by using this, I can actually get real types and actually use the compiler to verify that, like, okay, I can write this example that has this function calling this thing, and this function calling this thing, and see if it all type checks, because maybe the API I have in my head isn't actually going to work out in practice. This is a really quick way to figure that out. So the name of the library was actually not originally elm-css, because elm-css was the name of somebody else's library. They already made it. Now, Elm package does namespace things by username, so there technically would not have been a collision if I'd gone with the name elm-css from the get-go, but I didn't want there to be confusion, right? Like if you have one library that everybody colloquially refers to as elm-css, and then I come out with another library that whenever people are talking about it, if they didn't know about the first one, they would also colloquially refer to as elm-css, that'd be pretty confusing. So I decided to go with a different name, and I was like, okay, well, yeah, this is all about CSS, which is nice and concise, but it's also all about style sheets, being a preprocessor. So the name I went with initially was just Elm Style Sheets. Ironically, now, because Elm-css has been around so long, somebody else came out with something called Elm Style Sheets, and somehow it's not confusing anymore, so that's worked out pretty well. The end of that story was basically that the original person who made Elm-css stopped maintaining it, and so I was like, you know what, I think I'm just going to take this name because it's shorter. So I gave this talk at ReactiveConf, Bratislava, back in 2015, and it was just a lightning talk introducing the library. And this is a screenshot from the thing. And this was the DSL that I had back then. This was what it looked like to write Elm style sheets, as it was called back in the day. Now, you might notice some interesting features about this code. One is that there's this completely insane use of infix operators. This was a mistake. I didn't know it at the time, but this just seemed like a good idea. This kind of shows you where my priorities were back in those days. I mean, coming from a JavaScript background, I was very into this idea of syntax is a really big deal, and it's kind of the thing that I should focus on. And I was thinking nobody's going to use this if it doesn't look like CSS or it doesn't look like Sass. Familiarity is really important here. And this was before Elm format existed, so I didn't yet have the sort of mental sanity check of if I press save with Elm format, what is this going to do? If you can imagine, those of you who use Elm format, pressing save when you have Elm format on save, this would not look like this anymore after you did that. It would look just a big mess. Just to explain what I was kind of thinking, what was going through my head at the time, I was okay, so we have a dot, as it turns out. Back then you could put dots in operators. That's not the case anymore in master. And so that would represent a class. And so we have navlink. This is, again, that union type that was part of the original motivation. And then pound side, also in pipes, for an ID. And then I went with percent for bare elements because in order to get the types to work out, which I knew from debug.crash, I needed to have something here. I couldn't just put plain nav. The types did not work out. And so I put this percent sign here because that's what Hamel used for tag names. So and then we have the dash for the properties, and there's a couple of other design decisions that we'll get into, but one of the things that actually was pretty successful about this first draft was the fact that you can look at it, and even if you don't know the library, if you know CSS, this is pretty readable. The names correspond pretty well to the actual CSS property names. And I thought that learning curve was going to be really important because the CSS spec, as previously mentioned, turns out to be actually really big. And if you've invested a ton of time in learning it, investing another ton of time to learn some mapping between the enormous CSS spec and this library didn't really seem like it was going to be palatable to people. So having this kind of simple rule, going from kebab case with dashes to camel case like this, seemed like a pretty reasonable way to help people leverage that learning they'd already gone through. One other note about this was that, again, at the time, this was just a preprocessor, and so all I had done by the time I was supposed to go on stage and give the lightning talk was I had a demo in the REPL. You could take this whole long structure of union types that I built up and then call a toString function on it that I'd written, a custom one, and it would just spit out a big string of CSS. And I was there with Noah at this conference, and I was like, yeah, it's not going to be a great demo because all I could do is in the REPL. It'd be really cool if I had the CLI done because then I could actually show things on stage. And Noah was like, what if you took the string that you spit out and just put it in a style tag, and then it would work on stage? I was like, that would be so cool. So this is back before JavaScript libraries were actually doing this, which now today everybody's like, yeah, style tags, they're a thing. But 2015, people were like, style tags? What year is it? 1995? Nobody uses that. Style sheets or inline styles, which was just kind of a new thing. Of course, now today everybody's like, inline styles? Oh, no, it's a style tag, of course. But at any rate, so Noah had a great idea, and so I tried it out and was able to give an on-stage demo of this whole thing working, and it was really cool. Also at that conference was Mark Dalgish giving a full talk, not a lightning talk, on CSS modules, which, as it turns out, is a really cool idea for style sheets. So this first draft had some problems, but it was at least usable enough that it sort of proved the concept that it could work, that we could put together a DSL that would solve these problems. And sure enough, I was able to actually give a demo of just explaining what I just explained, hey, what if we could actually safely delete these things? I showed the type mismatch and that it would compile to a style sheet, and you could use variables like Sass. I could just have something in here that was any arbitrary value. That's just some constant that I'd set up above, and of course imports require all that stuff just leverages Elm. So it was already basically a fully featured preprocessor that I just kind of slapped together, as you can tell from the DSL. Okay. So these syntax concerns, right? This is what I was really concerned about, visual familiarity. When people looked at it, it looked like something like Sass or SCSS, less. I was really concerned about that. I had these sort of adoption fears, like nobody's going to use this thing. I'm going to put all this time into typing the whole CSS spec, and then nobody's going to use it because it doesn't look familiar enough. And I also didn't have Elm format on my radar because Elm format didn't exist yet. And actually, Elm format started coming into existence right around the time that I was working on this. And so I was talking to Aaron von der Haar about this, the author of Elm format, and there was kind of this question at the time where it was like, should Elm format support this? And then whenever you're faced with a conundrum like that, you kind of have this question to ask yourself, which is like, okay, I could ask this other community member to accommodate me, or I could look in the mirror and say, maybe I'm doing something crazy. Like maybe this is a sign that I'm doing something wrong, which is kind of ultimately where I ended up concluding, especially after I talked to Evan, who is not really big about syntax, and he kind of pointed out some things that I hadn't really thought about, such as, what are your error messages going to look like? If you have this gigantic chain of custom infix operators and the user makes a mistake, what's the compiler error they're going to get? Spoiler alert, not a nice one. But that's part of the UX of the library, right? I mean, this is Elm. Like, we rely on error messages to have a good experience. So that means, as a library author, this is something to keep in mind. What is the error message that your user is going to see if they make a mistake when using your library? On a related note, what are the type signatures that you're going to be presenting your users with? When they read your docs, are they going to be able to look at the type signature and think, oh, I get what that's for. I understand how this thing works. Or is it going to be something where they're like, whoa, what language is this? This is really long and really complicated, and I don't understand what's going on under the hood here. Simply with the type signature, that's like part of reading the docs. That's part of the user experience of learning how to use your library. And finally, there was the CSS learning curve, and this was something that I think, again, was a good part of the initial design. Like, keeping in mind that, yeah, actually the learning curve of learning CSS is a huge part of what it's going to mean to use this library, and I want to leverage that by keeping the names consistent, which turned out to be an important thing to keep in mind, because later on, this design goal came into conflict with some other things that I was trying to do with the library. Case in point, this. So margin 10 pixels. So this right here is an Elm function called margin. It takes two arguments. The first one's a number, the second one is units. Now, this works, and it looks kind of like CSS. Like, there's no colon, and there's a space between 10 and pixels. But it's kind of weird that it takes two arguments, right? Like, imagine if I wanted to make something, which, as it turns out, I later did, that combined unit measurements. Like, I wanted to say, oh, we want to construct some calculation of numbers. Like, I want to add these together. I want to keep the units consistent. I want to say 10 pixels plus 20 pixels and end up with 30 pixels. If I have these decoupled like this, and I have to pass them as two separate arguments to this, writing those functions gets a lot harder. I've made things a lot less composable by choosing this API for this function. Now, yeah, it looks more familiar to people who are used to CSS, but I mean, is it really that much harder to say pixels 10? I mean, not really, right? It's something that you kind of learn once and remember. So over the course of fleshing this out and kind of thinking about all the different use cases, I had to kind of go from 100% be as close to CSS as possible, leverage as much as possible people's CSS knowledge, to saying, okay, but I have to balance that against the other things that people are going to want to do with this library, and take it somewhere from like 100 to 0 to like, okay, maybe it's like 80% you can just use these mental rules to translate, and then like 20%, okay, there's a little bit more that you have to learn to be able to use this library effectively. Little things like this. So here's where I ended up. This is sort of the revised DSL, and this is the Elm format friendly one, because if you run Elm format on this, it actually stays the same, thankfully. This is the first revision. If you use Elm CSS today, you might notice that there's a little bit different. But let's just go over some of these things. So we see the pixels function that's taking 1280 as a number, and so that got corrected. That worked out nicely. We have a couple of different ways to specify colors. So you can do RGB, you can do hex. We can see other units here. So this is pixels, this one's percent. This is also another unit, 0. So this is an interesting consequence of doing the API this way, which is that if I want to have a function called width, which can take either percent or pixels, well, both of those encode in them unit information. Like, pixels and percents are different, and it's important that this function gets that so that it can emit the right one when it's building out the style sheet. Now, what that means is I have to specify that as some custom type that I've defined, which means that I can't have it just be a number. So I couldn't put in here margin 0, like the number 0, because that's of type number. And I had to have some custom type to carry the unit information around everywhere else. So pretty much the only way that I could let you specify an actual 0 that would compile into a 0 for the style sheet is to give you a constant called 0, which is a sort of a unitless number. Now, before I introduced 0, I thought I could get away with sort of a simpler version and say, oh, well, just pass px0. And that works, but it looks dumb. So eventually I was like, okay, fine, I'll just introduce a constant called 0, and it'll compile to an actual 0. So you didn't have to say px0 or pct0 or something like that everywhere. One other thing to note is that as I was going through and converting from this elaborate DSL of infix operators to this style, I was kind of thinking about this experience that I'd had in ReactiveConf with Noah's idea, and I was thinking like, okay, what if I actually later on want to use this for real? And as it turns out, we ended up using it at NoRedInk for real. And actually now we use elm-css as this is the first class way that we do all of our styles. And I was thinking okay, what if I want to put styles in the same view as the code that defines the view itself? Well, if I'm doing that, then I'm going to have probably, as we can see, unqualified imports for all these. I'm not saying css.color, I'm just saying color. So I'm probably going to say import css exposing ... Now, if I'm doing that and I'm also saying import HTML exposing ... if I choose the obvious name for this, which is ID, I'm just going to get a namespace collision there because I'm going to have ID from the HTML attributes package, and then I'm also module, and I'm also going to have ID from the CSS module, and those are going to conflict. So I said, okay, I'm going to get rid of almost all of the custom infix operators, but I'm going to keep ID in class. I'm going to keep the pound and the dot just so that I can avoid namespace collisions if I end up using these in the same page. This didn't last. Eventually, I kind of realized that this is hard to look for in the documentation. Would it occur to anyone to say, oh, how do I do an ID select? Oh, of course, I'm going to type in pound into Elm package. Not really. And when you're looking at it, it's pretty weird that, for the most part, you have all of these very normal-looking functions. Then in one place, you're using parentheses pound. This is something weird that you have to explain to people. You have to walk through the entire rationalization that I just did for how you're doing it. When instead, you could just be okay, look, just don't use that one in an unqualified way. Just say css.id, and then it'll be fine. And it turns out, yeah, it actually was totally fine. And same thing with dot. Dot went to css.class, and this is how it is today. Now, that does mean that if you're using html.class or html.id, that you have to namespace those as well, html.attributes.id and .class. But as it turns out, in practice, typically the way you end up using those with this library is with a namespace helper library of some sort. So you actually don't end up with a namespace collision at all because the library does it a little bit differently. One other thing to note is that I ended up doing a few other things differently than most traditional CSS libraries. So one of those things is namespaces. So namespace basic idea here is if I've got something in here called class navbar, all else being equal, what that's going to emit is a class that just says literally the string navbar. That's what's going to come out in my style sheet. Now, if you have a bunch of these going on the page, especially if you're reusing things like reusable buttons, reusable this, reusable that, there's a pretty high probability that you're going to end up with a namespace collision accidentally. You're going to have two class names that are identical, and one of them is going to stomp on the other one. Now, there are various ways to solve this. I think CSS modules has the best solution, which is that they generate the hash, the class name as a hash of the contents of the style, which is great because then you don't have to worry about any of this. But I didn't have a setup for that, and in fact, we still don't have a setup for that. So in the interim, basically what I came up with was this namespace way of doing things. So you specify this namespace string, and it just prepends that namespace to all the classes in the style sheet. So basically, as long as you have a different namespace for each section of your styles, then they won't stomp on each other. They'll end up with different prefixes when they actually get emitted to CSS. They'll all be fine. So that's one thing that was a little bit different. Another is how we specified making sort of combinators of selectors. So imagine that you have navbar less than sign, is that right? Yeah, less than sign li. So in other words, a navbar, and then it's an li element that's a direct descendant of that. Then I want to style that. So this was kind of tricky to come up with, right? So in CSS, the way that you're supposed to do this is you say navbar less than li, and then inside of that you put your styles. But what am I going to do? I'm going to go back to the infix operator style that I kind of spent all this time getting away from. And for the record, I actually did try that. I tried mocking out the DSL for that, having evidently not learned very much. But fortunately, I guess, it didn't actually compose very well if you wanted to have several of these in a row. So what I ended up doing was saying, okay, no, we're just going to have a function called children. We have a function called descendants. Descendants was another problem because the way you specify descendants in CSS is by using nothing. You just say navbar space li. And that really didn't fit well with this mode of doing things. So to be consistent, I have children, descendants, adjacent siblings, stuff like that. And all of them specify the different relationships, and they compile to the correct CSS. Now, this was the trickiest problem to solve, the trickiest design challenge I think I can safely say I ran into with elm-css. So I just want to look at this for a second. That was me stalling so I could take a drink. Just look at it for a second, and just think about what the types are going to be when I translate this to Elm. So we have margin, and it's 10 pixels. We can also have margin auto, we all agree. You can have cursor auto, which is part of the spec, and you can also have cursor pointer. Now, there's a bit of a problem here if one of our goals is to prevent invalid style sheets, which it is. So margin needs to be able to take 10 pixels. So that's a length unit. So margin needs to be able to take a length. Margin also needs to be able to take auto. Now cursor needs to be able to take a cursor value, such as pointer, but cursor should not be able to take a length. If I say cursor px10, I want that to fail to compile because that doesn't make any sense. That will generate an invalid style sheet. But I also want cursor to support auto. Here's the problem. What are the types of these such that it has those characteristics? Like, how can it be that cursor accepts pointer but does not accept 10 pixels, which means those have to have different types, but cursor accepts auto and margin accepts auto, and margin does not accept pointer? So they have to be incompatible and yet compatible in the case of auto. How do you do that? So I came up with this trick, and I guess it's, according to Evan, he said he hasn't heard of anyone doing this, so that's both a sign that it's probably crazy, which it turns out to be, but useful, and also just something that is sort of like pretty difficult for people to understand. So this was one of the biggest design challenges, was sort of figuring out, like, is this actually worth it? Like, is this worth, like, is getting this worth what I had to do in sort of like a dark secret ritual to make the types work out? But I'm going to explain what I did. So basically, I created this type called compatible, and all it is just to kind of make the error messages look a little bit nicer. So this is the basic idea. So I say margin is a function, right? This is the margin function, and it takes something that's an extensible record that has a field which is of type compatible. As we can see, compatible is very boring. This is just sort of a sentinel value that just says, okay, margin has a field called auto, and it has a type compatible. So basically, I'm saying margin is auto-compatible, like it's compatible with the auto value. Then it takes a snippet and returns a snippet. So that's basically, after you've passed it this value, then we're going to have square braces, and inside of that are going to be all the styles. So that's not the interesting part. The interesting part is this extensible record here. So the idea here was, okay, as long as both auto and 5 pixels have that auto-compatible field, even if they have other fields in them, this function will still accept them. But of course, I wanted it to be able to accept lengths too, so I said, oh, I'll just add length compatible. Now this doesn't quite work. This is sort of where I started with this. Is like kind of the initial inception of the idea. I was like, okay, so I want it to be compatible with auto and also to be compatible with length. Turns out, though, that doesn't quite work. So pixels should have a length compatible, but it should not have auto compatible. Because if pixels are auto compatible, that means that anything that accepts auto will also accept pixels, which, like, for example, cursor. So that wasn't quite going to work. So this type right here, it was like the idea was almost there, but it didn't quite work. Turned out, this is the solution, saying length or auto compatible. And then basically, the pixels function returns something that is both length compatible, so functions which only accept length but not auto will use an extensible record that says I take length, but not length or auto. But also, the pixels record has to return that it is length or auto compatible. This is very janky, and as you can imagine, there's sort of a combinatorics issue here, right? So I want to support length or auto. What if I want to support length or auto or none? What if I want to support length or auto or this or that? So I knew that going down this road, but I was kind of like, well, I mean, the CSS spec is large, but it's also well-defined. I mean, I can look these up and see just how many combinations there are. There is a finite number of combinations, even if it might be kind of a ridiculously large constant. Here's what auto looks like as a result of going through this strategy. This is really what auto looks like. It actually does have to have all this stuff. So it's length or audible compatible, which is why margin can use it. It's cursor compatible, which is why cursor can use it. Also flex basis, overflow, text rendering. I mean, all of these things, you just keep running into these scenarios, and then somebody has to make a PR that adds one of these so that we can support some new function that needs to take auto. So would I recommend doing this for your library? I'm just going to default to no. This is a concession to CSS, right? This is like not something that I've ever used in any other library. It's basically just CSS is huge. I think it's really important that in order to use this library, people are able to look at it and apply this simple mental transformation of kebab case to camel case and get 80–90% of the way towards knowing the library. But as a general rule, I really don't think this is a terribly good idea. It's really just kind of a hacky solution to a problem that ends up working out well. Keep in mind that this also goes against several of the other design principles we talked about, right? So like nice error messages, this does not lead to nice error messages. Like if you have something that messes, yeah, I mean, you can imagine what this does. Documentation, like I think I made a type alias for auto just to hide all of this and then put that in the documentation because, I mean, it's kind of a giant mess. But at the end of the day, CSS spec is huge and have to make, trade-offs to in some cases just outright concessions if you want to save people from having to go through all that learning curve again. I just came from Elm Europe, and at that conference, Matt Griffith demoed a library that's basically aiming to take a different approach to styling, which is really interesting. And basically, he didn't base his library on CSS, so he doesn't have that design constraint, and he can make a different choice. And I haven't looked at his code, but hopefully he's not doing this because he shouldn't need to. I think in general, a much better piece of advice is design the simplest API you can that gets the job done. And that's sort of going to be a recurring theme for pretty much the rest of the design of both of these libraries, except for that one piece of elm-css. Another case where you can have sort of tension between these goals came up when it comes to left and right and top and things of that nature. So let's think about the types of these again. So we have position absolute, and you want to say left 5 pixels, so it's positioned offset left 5 pixels from the left. So that works. And then you also have float left. Both of these are things that exist in the CSS spec. CSS spec, turns out there's a lot of overloaded values in there. So here we see that the type of left has to be a function. There's no possible way that it could be anything but a function. Also, there's float left. Now in this case, as we've seen from a moment ago, this needs to be one of those extensible records because you can have float none. And none is like auto in one of those things that needs to be this crazy looking record in order to get the types to work out. So we kind of have a problem here. On the one hand, we need left to be a function. On the other hand, left kind of can't be a function. So what do we do? So basically, in a case like this is where I had no choice but to make some sort of, I had to resolve the tension by just picking something and just saying like, okay, either I need to rename left or I need to make float take a function and just deal with the consequences of that as it pertains to other things. The decision I ended up making was to make this work, to make what you see on the screen work, and to say left is a function, whereas position actually takes one of these records, float takes a function. Doesn't really make a lot of sense if you think about the types, but it does work out that if you look at the DSL, then things sort of work out the way you might expect. And the reason I came to this conclusion was based on my experience with a different library, and this library was Decode Pipeline. So when I was building that, I initially, again, I had this mindset of kind of like syntax is a big deal, and I want to put together something that looks nice when you read it. And as it turned out, in that case, that worked out pretty well because the user experience of resolving errors in Decode Pipeline is actually pretty nice. Like you don't need usually to look really carefully at the compiler error messages to figure out what's wrong. You can usually just look at the code and say, oh, I see what I did. It's this problem. So just the fact that the compiler points you to the right general area tends to be enough. Once you can look at the code, you can figure it out. And it's kind of the same way here. If you make a mistake with one of these things, okay, yeah, left is a function, that's really weird. It's not good for the documentation. The documentation for left is weird as a result of that. But if you make a mistake in some code like this, usually you can just look at it, figure out what you did wrong, and fix it. So this experience sort of led me to make that decision in this particular case. Was this the right design? Like, did I make the right choice? I mean, at the end of the day, the only way I can answer that question is just to learn from feedback. Like you have to make a choice based on all the information you have, and that's can be a tough thing in and of itself to decide when you have enough information to make the decision. Sometimes the answer is, I just need to gather more data. I need to get more input from people. I need to try more things out. But I felt like I had enough data to make the decision, so I made it, and then been able to learn from feedback ever since. People have been using the library for a while, and basically, this hasn't been something that people have complained about. So that sort of tells me that at least it was a defensible decision. Like it was not something that I was like 100%, oh yeah, this is definitely the way to go. But considering the trade-offs I had at hand, it seems like the fact that people haven't felt like this is giving me nasty error messages and I don't like it, at least is a sign that it was at least a defensible decision. Something that cannot go unsaid is that community contributions are essential when you're making some library like this. Like we've got a bunch of different people that have contributed to elm-css over the years. The years being 2. One of whom is Luke Westby, who gave a talk earlier. This is actually the first Elm project that he contributed to. And it's important to remember that community contributions don't always come in the form of commits like this. Like this is kind of the most visible because you can see it on GitHub, but it's really important to consider community contributions from a design perspective. Like when you're thinking about all the different designs, like talk to people about your designs. Like go into Slack, go on Elm Dev, just put it out there and say, hey, I'm thinking about building this. Here's what I had in mind. What do people think? Because a lot of the times there's use cases that you hadn't considered, or there's feedback that can change your mind about something, and immediately as soon as you hear it, you're like, I did not think of that, and that immediately resolves my problem. Or I did not think of that, and I really need to rethink a lot of these things. And you can save yourself a ton of time by hearing something from somebody early on and making a different decision than if you plow through with implementation in the dark and then end up finding out much later, if I'd known about that a month ago, it would have saved me a ton of time. So something to keep in mind. Community contributions, not just from code, but also from a design perspective. Some of the long-term goals of elm-css, I'm not going to spend a ton of time on this because I wrote this up in a wiki article that's on the elm-css repo, but basically some of the things that I'm keeping in mind here is, number one, what else is out there? Like now that we've got this library, like the state of the art of CSS in JS has sort of advanced, right? People are doing different things. This rendering to a style tag that was novel back in 2015, there's a bunch of libraries that have done that. They've compared the performance of doing that versus doing style attributes versus compiling to a separate style sheet. They've looked at all those trade-offs and they can write up things that let us learn from what can this do for elm-css. There's this big question of build time versus runtime. Like, what are the trade-offs associated with doing that? So part of it is pseudo-selectors and things like hover and media queries. Like, those are things that you can do at build time. There are things you can do at runtime if you do it with a style tag, but not things you can do with a style attribute. What are the trade-offs between those things? Like, is it better to go for optimizing for build time or optimizing for runtime? Should we support both, which we currently do? How do you balance all these things? These are lots of important things to think about for the long-term health of the library. Is inline style something that's worth supporting? And even simple questions like, if you're going to go with a style tag, does it need to go in the head or does it even matter? Right? So this is something that JavaScript libraries actually go out of their way to do. When they write to a style tag, they put that style tag in the head. This is an interesting question for me to ask because right now, elm-html has lots of ways to put stuff in the body, but it would require some new language feature or some new library feature of elm-html to be able to put that style tag in the head. So is that something where I want to try and advocate for that, say, hey, I need this. I need to be able to put my style in the head? Or does that even matter? Would I just be introducing a complication to somebody else's library for nothing? This is a question that I can't answer just by looking at what else is out there because this is what everybody else does. And so I have to sort of like research what else is out there. Is this something that I should put on my long-term radar or not? Lots of things to consider. Okay, so let's talk about elm-test, the other library in question. This was a very different experience. It started from a very different place, and I learned a very different set of things from working on it. So elm-test 1.0, I had nothing to do with. elm-test 1.0 was one of my favorite dependencies to install because of the user who created it. So this was back in Elm 0.15. Alex Neslucin? I'm not sure how to pronounce his last name. But his GitHub username was deadfoxygrandpa. And so every time I would look at my Elm package JSON, that would make me smile a little bit. Yeah, so he made the initial Elm test, and the output looked like this when you would run one of these things. This looks pretty different from Elm test today if you've used it. So basically, this was sort of the very initial Elm test that ever existed. This was sort of basically focused on just making something that worked, right? Alex didn't end up spending a lot of time iterating on this because he ended up sort of, I'm actually not sure what happened to him, but I haven't seen him around in the community really. I think he kind of wandered off and life happens. And so basically, this was what we all wrote tests with back in the day. And so you can see the output's got like this notion of suites, and the tests inside the suites tells you how many passed, how many failed. If something fails, it says, okay, in this suite, all the tests passed. In this other suite called some other tests, it failed, and then it gives you some output about what failed. Like 8 is not equal to 1. I expected 8, and I got 1. 3 equals 3, that passed, great. True, passed. This thing passed. All these tests passed. So there's a lot of output here, but you can kind of tell just from looking at it that like this was not something that there was a lot of time spent optimizing this and like thinking about what's the best user experience for the output of this. It was more just like, let's get 1.0 out the door, let's make something that people can use, and then we'll iterate on it later. But the iteration part never actually ended up happening. So when I was preparing, so I did this course for front-end masters, and I was doing these workshops leading up to this. That initially I was doing them in Elm 0.16. And back at that time, I would go through the workshop. It was like a 2-day workshop. And almost all of it, people would be like, this is great, this is really great, this is really awesome. Until we get here, and they would see this output, and they'd be kind of like, yo, is this like alpha? Like what's going on here? And it was kind of like jarring for them. It was like kind of incongruous with like how nice the error messages and everything else had been throughout the rest of the course. So this kind of like stuck in my mind. I was kind of like, yeah, I really wish like I could help make this better. I was like, I should really talk to Alex about this, but he was kind of like getting less involved, and so I never really did. Another thing that we used to use a lot was elm-check by Hassan Hayat, another community member who I think he got like a job or something and then ended up not having time to be the most prolific Elm author, which he certainly was at the time, like back in 0.15. all of the, if you're using like JSON extra, list extra, something like that, just like dig through the history of commits on. There's a pretty good chance that that library got started by Hassan back in the day. If you're ever in Morocco, I don't know, maybe look him up. So this was what elm-check looked like. It had this DSL that was based on backticks. So depending on how recently you've come to Elm, you may be like, what are backticks? Because they're not in the syntax anymore. But again, Elm 0.15, they still existed, and so this was the DSL that he made for doing these. So elm-check was basically this sort of quick check style, quick check in Haskell, maybe JS check in JavaScript. I think there's some other JavaScript libraries now. I used to use JS check back in the day by Douglas Crockford. And there's like many others of these. Sometimes it's called property-based testing, quick check style testing, generative testing, fuzz testing. There's lots of different names for this. And so this is what we used. It was this decoupled library that was built on top of the elm-test library that Alex had made. And then all of a sudden, we came to like an upgrade period and we needed maintainers because both of them had ended up, sort of drifting off and going on to other things. And so neither of these libraries had a maintainer. And I'd been kind of thinking about like my experience with teaching students this and feeling like I really wanted to contribute to the CLI output and try to make a nicer user experience. And so I kind of like raised my hand and was like, yeah, I'll take this over. I'll take this on. So whereas elm-css, this kind of came from an idea. In the case of elm-test, it just came from like, there was an opportunity here. It was like, we needed somebody to take this over. This is important libraries for the community, and I was like, okay, I'll step up and do it. So at this point, I was like, okay, why don't I take a step back and not say like, how can I maintain these libraries, even though that's the position I found myself in, but like, how can I like set a vision for this thing and like the future and think, how can we design the best testing experience? Like just aim as high as possible and say, how can we make elm-test so nice that someday, if we realize that dream, people will say, I want to use Elm because the testing experience is so great. To my mind, it's like, why settle for less than that? Why not aim really high and say, like, how can we make this as good as possible? So to do this, I had to sort of like think philosophically about not just like what are my immediate needs, what are my immediate experiences with testing, but also just like testing as a whole, like the concept of testing, like what are the things that make testing difficult? What are the challenges that people face when writing tests? And I think incentives is actually kind of an underrated problem when it comes to tests. So here's the thing about tests. Like the path of least resistance is just not to write them. You can just ship code that has no tests and it'll work, and your end users won't nominally have any idea. Now they'll probably have some clue because after a while you're going to maintain it and stuff's going to break, you're going to get regressions. But the path of least resistance is just not to do it because when you've got a deadline, you're trying to ship something, if you're not doing test-first development, I mean, it's pretty easy to just get something out the door that has no tests on it whatsoever. So I was thinking about this and thinking, is there something we can do about this? And kind of the conclusion that I came to is, yeah, minimize friction. Like the less effort that it is to write tests in the first place, to get up and running with them, the less it's going to be the path of least resistance to skip them. So how can we remove some of that resistance? And I think this is a really important idea for tests. So this suggests philosophies like batteries included, like just have as much stuff there as possible. Make it as easy to set up as possible. Make it so you can run one command and it'll just generate your tests from scratch so you can just get up and running and not have to fiddle with documentation. All of those things that you have to do to get up and running are more and more opportunities to just wander off and say, you know what, I don't have time for this, I got to ship something, I'm not going to deal with it right now. And then of course they never get written until it's too late and now you have regressions. So this again sort of shaped the design goals of the project, of elm-test 2.0. So we had sort of the first design goal was make things as frictionless as possible to set up. Another one was to have a short feedback loop when tests fail. So this is another thing that I think contributes to people not wanting to write tests is like you write a test and it fails and it just said test failed and you're like, why did it fail? I want to know why it failed. I want to fix it so I can get back to my other thing that I was working on. So having a shorter feedback loop by giving you more information, ideally giving you enough information such that you don't even need to rerun the test with debug.log or some other instrumentation to figure out what went wrong. Just right there in the failure message, you have all the info you need to figure out, I see what the problem was. I now know exactly what I need to do, either to fix my test or to fix the code. And then finally, going back to Hassan's elm-check library, I said, yeah, I want to support this really well. I want to support quick check style tests in a really nice way because this is just something that I think should just be pervasively available. Like Hassan had elm-check the library, and then there was a separate elm-test library, but there were some places where the two didn't line up super well. For example, because elm-check was implemented on top of elm-test, if you were writing elm-test tests, like unit tests, and you're also writing elm-check tests, every time an elm-check test would run, it would add 100 iterations to your test count. Like you would write 5 normal unit-style tests, then you would write 1 quick-check-style test, and now you'd have 105 total tests. And so your total test counts just got way out of whack because of this. Also, when one of these things would fail, it wouldn't be able to tell you, like elm-test couldn't tell you in the CLI output which randomly generated inputs caused the test to fail. It just didn't have that information. So my thought was, couldn't we just integrate these? Like, if this is something we want to support really well, couldn't we just make it so that this was built into the test runner? It had this first-class notion of doing this style of testing, so it could give you really nice output, both in terms of test run count, in terms of the randomly generated values that led to the failure. Couldn't we just do that from the get-go? Why not? And so this led to this concept of fuzz tests. Went with the name fuzz basically because, like I said, it's called quick check style tests or property-based tests or generative tests, and fuzzing, according to Wikipedia, is also a valid definition of this. And this was both the most concise and the most fun to say. So clear winner to me. So this is the DSL we ended up doing, and this is the actual front-end master's course where I was able to demo this, brand new Elm test to people by the time the course actually came out. So the API is you call fuzz, and you pass in a fuzzer. There's also a fuzz2, fuzz3, and you can use tuples to build arbitrarily large fuzzers. You pass in a string for the name of the test, then you get a function that just takes the randomly generated output. So this is a list of ints, so you'll get a random list here, and each time the fuzz test runs, it's going to run this anonymous function 100 times, each with a differently randomly generated list of integers, and then inside the body of the function, you just build up this expectation value with expect.equal, and then just that's basically your assertion for what happened in the test. So this is pretty easy. It's pretty easy to use, and it was sort of almost no trouble to do fuzz tests. Like if you want to look at the unit test version of this, only 2 things are different. You don't have this list int because there's no fuzzer to specify, and instead of passing in a random list of integers here, it's just going to pass in unit, like a useless value. So what that means is that also, if you are writing a unit test and you want to convert it to a fuzz test, this is super easy. Again, this theme of like reduced friction. I believe that quick check style tests or fuzz tests are really valuable, really useful things. And I think that a lot of the reason that people haven't used them historically as much as they've used unit tests is just that it's more of a pain to set them up. You have to install this separate library. Usually you have to go way out of your way to call things. It's like, what if the API for this were just really easy, really close to the API you'd be using otherwise? In a lot of cases, for me, it's easier to write this because rather than having to set up a dummy list of random values, I can just generate one. In some cases, it actually saves me time as someone writing the test compared to if I were writing it using a unit test. I think that's a really important idea. Then I ran into this problem, which is like I have this cool design, but I lack the domain knowledge to actually do a good job implementing it. Fortunately, there are other people in the community. So Max Goldstein, who I knew from San Francisco Elm meetups as well as GitHub and other places, was the author of elm-pcg random. And this is basically a random number generation library that he made from scratch. And it has statistically significant superior statistical properties to the core implementation of random, which is to say, this is a random number generation library that is more random than another. I didn't even know that was a thing. Like, I didn't know you could have more randomness than others. Turns out it is. And I knew that he published this library, and I was like, cool, I want to do these fuzz tests, and like I want them to be really good at random number generation and to generate useful distributions of things, like getting like nice values, like, okay, we want to have some zeros in there, we want to have some negative numbers, some positive numbers, things like that. And so I kind of reached out to Max, was like, hey, do you want to collaborate on this? You have domain knowledge that I lack. Turns out also Max was really interested in shrinking. So shrinking is a really, really important feature of fuzz tests, which I know because one time back in the elm-check days, I wrote one that was really slow to generate errors, really slow to shrink, and I turned it off. I turned off shrinking, and then I saw the output, and I was like, oh God, please put the shrinking back. So what shrinking does is basically it takes your randomly generated value, and if that leads to an error, it says, okay, so this randomly generated value, which was, let's say, a list of strings, so this list of strings happened to be 64 strings long. Each of them is random gobbledygook from between 0 and 1,000 characters long, and that's the error message you get. It's like, hey, this failed. Here's what caused it to fail. Blah! And you look at it and you're like, what about this caused my test to fail? I have absolutely no idea. I'm so scared. And so basically shrinking says, okay, we found a failure case. Cool. Let's take that and let's try to make it smaller. And there's some definition of smaller for each of these different fuzzers. So for like a list of strings, let's say let's try to make the list smaller, the list shorter, fewer elements, and let's try to make the strings shorter. And it'll rerun a bunch of these conceptually speaking. I'm hand-waving a little bit here, but conceptually it will rerun the test with these shrunken values until it gets one that passes. And then it'll say, okay, cool, now we know which one fails, like the shortest possible thing that will fail this test. So if you've ever run elm-test and you've been writing a fuzz test and you see an error message and it's like, hey, this failed with like a list of empty string comma -1, and you're like, oh, that's it. That's what causes this test to fail. It's that -1 or something like that. That's thanks to shrinking. Now, I didn't know how to implement shrinking. I really had, like, I conceptually knew how it works, but I really didn't have any idea. Fortunately, I don't know if Max already knew or he was just, interested enough and had enough domain knowledge to figure it out. But basically, this was his baby. This was like his, the thing that he made happen in elm-test 2.0. Also, of course, he contributed to design. Again, anytime you got other community members involved, like bring them in, like talk to them about the design that you have in mind, and like bounce ideas off them, collaborate on the design as well as the implementation. So this is where we ended up. This is basically the fuzz test output of the new Elm test. So we have sort of much more concise and sort of, prettied up output, like in terms of you can see the descriptions of the nested suites. You can see the error message, or sorry, the name of the test that failed. We've got this given thing, so actually it will tell you, here is the exact randomly generated input that caused this test to fail. And then we've got this expect.equal thing that sort of shows you, here's what we expected and here's what we got. And this is basically designed to line up with a pipeline style of building up your expectation, such that if you put your code side by side with this message, this will be what's at the top of the pipeline and this will be what's at the bottom of the pipeline. The idea behind this was basically that I always found that whenever I had like an expected versus actual, I could never remember which was which. So it'd say, hey, I expected this and I got this. I'm like, cool. But which one was the expected and which one was the actual in my test? So just having this like simple heuristic that I could put in the documentation where you could be like, put this side by side and they'll line up and then you can just look at that, made at least my life a little bit easier. I don't know if that's been useful for other people, but certainly seems to have made sense at the time. So another thing that I think is important to note about elm-test is this idea of designing invariants up front. So you always have to be careful about designing too far for the future. Like it's pretty easy to say, we're going to do this. This is going to be amazing, and then you never actually get to it. Or maybe even that design causes you problems in the course of getting to where you actually are. But when it comes to invariants, I think these are things that you want to at least try to establish up front and then maintain over the long haul. So one of the invariants here was I wanted to be able to, for all the tests to run in parallel. So at this point, back in the day, there weren't really large test suites. Like those didn't really exist. I mean, we had a bunch of tests, but I mean, they all ran in a matter of seconds. But something that I know about tests, just from working on various code bases of various sizes, is that over time you get more and more of them. Eventually they're going to get slow. And once they've gotten slow, there are certain well-known tactics for making them run faster, one of which is letting the tests run in parallel. And so this is something that I wanted to be true from the get-go. I wanted to make it so that when that day came, because it was pretty predictable that that day was going to come, and now we're there, now our test suite at work takes over a minute to run, I wanted to be able to potentially improve performance there by running all the tests in parallel. And that's true even of the fuzz tests. So it's pretty easy to make the unit tests run in parallel. All you have to do is just make sure that they're wrapped in some sort of anonymous function so that they can have delayed execution. But for the fuzz tests, it's trickier. Another thing was that I wanted all the tests to be deterministic given a seed. Now this is necessary for one thing if we want to have parallelization, but for another thing for reproducibility. So what happens if you run a fuzz suite and you've got all these iterations running all these different tests and that you find some crazy edge case that's like, oh my god, I had no idea that this combination of inputs would fail the thing, but sure enough it did, and you want to reproduce that. I wanted to be able to say, okay, cool. The output includes a seed value that you can then pass off to your coworkers so they can immediately reproduce that crazy unlikely event that you saw. And so basically, in order to do this, I wanted to set these invariants up front because I know that invariants are a lot harder to introduce later. Like if you've got something early on and you're like, okay, it must be true that all tests can run in parallel, all tests are deterministic given a seed. If you've got those established up front, later on if you change your mind and you're like, actually, you know what? I have a really good reason that they shouldn't be deterministic given a seed, so we're just going to throw that one out the window. Really easy to get rid of it. Once you've been building on top of a foundation that does not include these invariants, much, much harder to introduce them later. To say like, hey, everybody, I know we gave you this thing, but now we have to take it away because it turns out that was preventing this other important thing. Sorry, please don't hate me. Really a good idea to try and keep invariants for as long as possible. So seed distribution was sort of the solution that solved at least those first two, of wanting to be able to run tests in parallel, including fuzz tests, and of wanting fuzz tests to be reproducible. So basically, this is what enabled us to end up having this thing right here, this -- seed argument that comes into the CLI. So basically the idea behind seed distributions, you start with one value, one seed value, and it's either this number that you pass in from the command line, or if you didn't pass one in, then it randomly generates one to be the initial seed value. So it starts with that seed, and then it uses something in Max's elm-pcg random library to split the seed. So it's like take a seed, given that seed, randomly generate a new seed, randomly generate a new seed. And it just goes through to every single test in your suite, and it assigns each of them, a randomly generated seed to use as its own starting point. And then every single fuzz test operation is implemented in terms of a seed. It just runs the test, given the seed, gets a new seed. Runs the next thing, given a seed, makes a new seed. So each of these tests, they get distributed these seeds initially, which means that now we can run them in parallel, because every single test in the entire suite that you specified is going to get a fixed seed at the beginning. So if I spin up 4 different workers, and I say, I want to run these in parallel, I'm going to say, hey, worker number 1, run the first test. It's like, cool, I'm going to run that. It's going to be deterministic based on that seed. Worker number 2, run test number 2. Cool, it's going to get the same answer. And so every single worker can be completely independent of the others, and they're all going to get identical answers because fuzz tests are completely deterministic given one of these seeds. This is like a very long game because we actually haven't implemented parallelization yet. Still, in the works, but basically because of this design, it's going to be possible whenever we do get to it. Another thing we wanted to have was fuzz.map and fuzz.andthen. So these are basically ways to combinators for fuzzers. And out the gates, we couldn't do this because we'd basically translated Hassan's original Elm check implementation to this new API, and it didn't support these. But we wanted to. We wanted to let people combine fuzzers in this way, fuzzers being both a specification of here's what random values I want to generate, as well as here's how to shrink them. So it's those two things put together. And so if you can compose fuzzers, then the end user doesn't have to know about shrinking. They don't have to know about this idea of shrinking. Previously, the only way you could compose these things, you had to separately say, I want to make a new fuzzer, here's how to generate its values, and also here's how to shrink them. So the users of the library had to know about that concept. This let that become an implementation detail they no longer had to care about. The solution to this, to do a lot of hand-waving, and I'm not just hand-waving because I want to save time, but also because I actually don't understand how this works. This is also something that Max knows about, has domain knowledge that I do not. But basically the answer is these things called rows trees. It's this data structure that makes it possible to implement those two functions. And to implement this, we actually started off by doing a little bit of open source archaeology. So as previously mentioned, Hassan sort of disappeared. We're actually kind of worried about him in the community because he just kind of stopped communicating. Everybody was like, what happened to Hassan? Is he okay? And then eventually he showed up later. He's like, hi, everybody. I'm good. I'm busy. Bye. And so glad to know that he was okay. But basically, we were talking about how to do this rows tree thing, and Max was reading papers about how to do it and looking at how Haskell does things. And it kind of came out at some point that somebody was like, hey, I think Hassan was working on that. We're like, he was working on it. Maybe he had a branch pushed where he had at least some proof of concept done. So we went and dug into his old Elm check library from Elm 0.15, and it turns out, yeah, he had a branch where he actually got it working. so we dug it up and ported it from 0.15 to 0.17, and just oh man, remember this syntax? So this used to be a thing. That actually worked. I don't know how much of that actually ended up in the final implementation, but it was certainly a useful starting point. So it was pretty cool to see that. So then basically Max implemented this. How many different ways can I substitute Max for other words? And fuzz.map proved very, very useful. Fuzz.andthen proved useful in theory, but it may have actually been a mistake, as we later learned. So as it turns out, when you write things with fuzz.andthen, there's a very high probability that you probably should have used something else, but this was sort of the path of least resistance, and it seemed good, and then it causes problems later. So we're actually currently in the process of debating whether we should make a breaking change and take this away. So this again goes back to this idea of it's better to establish invariants up front. If you're wondering whether you should introduce a function or not, if you're kind of on the fence, usually better to default to not introducing it because it's a lot harder to take something away later once people have been depending on it, if it turns out it was a mistake and a foot gun, than it is to just not introduce it in the first place and just wait and just say, hey, can somebody come up with a use case where it's not possible to do what you need to do without this existing? So this was maybe a mistake for us to include this. We kind of got excited and just kind of threw it in there because we could once we had the rows trees. But fuzz.map, very, very useful. That's an extremely useful combinator, and nobody has any interest in taking that out. Here's another debug.crash without context slide. So once again, we use debug.crash, and in this case, it was not for designing the APIs, but rather this was for our favorite premature optimization. So this was my fault because I basically had this idea that we wanted it to be really fast, and it's really important for your tests to run fast because everybody knows when you get a slow test suite, it sucks. So we want to make everything as fast as possible. And in particular, I was like, we want to make the happy path really fast. Like if your tests are passing, like on a CI server, we want that to be super fast as possible. And Max was like, okay, cool. I think I can like take some shortcuts with the shrinking. And long story short, one of them involves, rather than using like a maybe, it was like, we can get away, we can save some allocations if we use a debug.crash in this one branch instead of something else. Shockingly, this made the code harder to work with, as one might imagine. So it turns out Elm has these useful data structures for working with like potentially things can happen or not. Like union types, turns out they're really nice. And when you don't use them and instead use debug.crash, stuff gets harder to maintain. You get bugs, which we did, and then you later on wish that you were able to take it back out again, but you're not sure if it's going to cause a big performance problem. Fortunately, between then and now, Elm Benchmark came out, thanks to Brian Hicks, who's also here. And my coworker Jasper Rodenberg used this to benchmark it and find out if this was a premature optimization or not. Maybe it was. Maybe it didn't actually make a difference, and it was actually a rounding error as to whether or not this actually made any difference. Maybe, hypothetically, we ran the benchmarks, and it looked like taking the debug.crash out actually improved performance because it was within the margin of error. No one knows the answer to these questions, but yeah, long story short, don't prematurely optimize, and especially be very, very careful of using debug.crash for basically anything other than like API design or something that you're going to be only doing temporarily. Again, community contributions, like lots of people have contributed to elm-test, and not only to elm-test, but actually to peripheral libraries that are related to elm-test. So not only did I lack domain knowledge when it came to fuzzers and shrinkers, but also to a great many other things. As it turns out, there's a lot of domain knowledge that I lack. It's something I'm very good at, lacking domain knowledge. Elm-html-test is a great example of this. So Noah Hall, who's also here, turns out like all the people who've contributed to these libraries are at this conference, which is cool. So Noah had built basically this server-side rendering project in Elm, which sort of morphed into a way to run view tests, which we were using at work. And we've been using this for like quite a while without elm-test having any sort of like formal notion of this. And basically, it was a way to say, okay, we know how to test functions. We know how to test like update functions and helper functions and decoders and encoders. We don't really have a nice way to test the structure of a view, though. Like if you can actually say, I want to render this HTML and I want to look at the structure of the output and test that. At the time, I was really big into the idea of just, okay, let's just use like Selenium tests for everything. Like WebDriver, Capybara is what we were using at the time. Because that gives you like the most information when you run those tests. Remember how I said like test suites being slow is kind of a thing that you have to worry about? Turns out, if you don't have to spin up an entire browser to run these, your tests run way faster. And that really matters. And so basically, Noah's solution allowed us to implement these tests that were testing the structure of our views and ran really, really fast. They were really, really nice to run, and they had a much shorter feedback loop than having to spin up an entire browser and run through stuff before you found out that they failed. So the usability was better. This is a good thing. And basically, past a certain point, I was like, okay, this is really cool, and I have this batteries included philosophy. I want things to be like as sort of low friction as possible to introduce this. So I went and talked to Noah about like, hey, let's see if we can like make this be the batteries included solution. Like, let's see if we can bring this in and make it so that people can just pull this off of Elm package. Because one of the things you might be thinking is like, how do you actually like look at an HTML value, which is an opaque type, and make expectations about it? And the answer is that you can't. You need to be able to look at the underlying like kernel implementation of HTML, like go really, really under the hood. If you're going really, really under the hood, Noah's the guy you should talk to because he knows all this stuff. And so basically, we're kind of like, okay, so is there a way that we can get this onto Elm package? And basically, that means we have to talk to Evan. So be like, hey, Evan, we have a compelling use case, we think. We think this is like really important. We've been using it ourselves. We've done the experiment. It's really valuable. We think this should be batteries included in the test. What do you think? So we talked to Evan, and basically he was like, yeah, this makes sense, cool. And while we were at it, so also had an opportunity to do an iteration on the API and like the implementation details. And so this was where this kind of idea of incremental failure messages came in. So basically, I was pair programming with someone at some point and realized that once we got to the end of our test, we would go back and we would see the failure. We'd go back and add debug.log to figure out like what was going on with the queries incrementally, like along the way. And so I kind of had this question of like, can we actually give the user that output eagerly? Can we sort of design an API such that as you're going through, it's building up a memory of all of the queries that you use to descend down your tree to find the thing that you wanted to actually run the assertion on, such that at the end, if you got a failure, it could just show you, okay, first I did this, I had this big blob of HTML, then it reduced down to this, then down to this, then down to this, such that you would no longer have any reason to go back in and add debug.log instrumentation unless it was to look at some sort of intermediate variable. So then there was this other idea of, okay, we can test the structure of the HTML, but what about the interactions? Like, what happens if a user clicks and it generates some event? I had this kind of idea at some point. I was talking to Aaron Vonderhaar about this. I was like, I really want to be able to test errors. I want to be able to run the test and have it assert that if the user clicks on this button, it's going to generate this message and send it to update. And the idea here was to sort of close the loop, right? Like, you can already write tests on update because it's a function that returns a model and a command, and just look at the new model that came out. Just throw away the command and say, what is my resulting model when I get one of these messages? So the idea behind closing the loop was, if I can do that for update, and I can also test view and say when the user does this interaction, it generates that message that causes update to do that, then I can actually test the complete interaction of the system, like all the state changes, without spinning up a browser. This is a really cool idea. And I was talking to him, I was like, yeah, someday I'm going to get to this. Like, I just really want to do it. I just don't have time right now. I'm writing this book, like all this stuff. And I was like, if only, here's a pull request that does this. What? So Rogerio Chavez, I hope I'm not mispronouncing his last name, but he just made a pull request for this in the dark, like without talking to anybody. He was like, hey, I came up with this idea and I just implemented it. Here you go. I was like, whoa, what? How did this happen? So in general, like, this worked out really well, and we like talked about it and gave feedback and merged it and everything, and now it's out and you can use it. But in general, I really would avoid doing this. There's a really big risk if you do this. If you make a big pull request without talking to anybody first, that the feedback's going to be, actually, you missed something and we shouldn't do this. And like, not only can we not accept this in its current form, but we just should never accept this because this is going to cause these problems, and it's like going to lead to these pain points for people. So this might have worked out very differently. I'm happy that it ended up working out really well. But just like as a cautionary tale in general, if you're thinking about making a contribution to something, start by talking to people. Like, always reach out to people first. That's the way to get the best result. Another thing that we wanted to do was to run subsets of tests, like not run your entire test suite, but just be able to run, like, I want to run just this one file or this set of files, or maybe even within a file, run some subset of the tests within there. This is something that other testing frameworks like RSpec and Mocha and all these things have different ways of doing this. So we wanted to support this. The initial way that I had to do this was this thing called test.filter. The reason I shipped this was basically that it was really easy to implement. And basically, you gave it a string, it went through and took the structure of your test and just greped that string, and everything that matched that string it would keep, and it would throw away all the other tests. This was flawed in many ways and basically sucked to use. And so we're sort of thinking like, okay, can we do better than this? And of course the answer was yes. So we ended up with, after a lot of design discussion, with test.only and test.skip. So these are pretty obvious functions, but there's a pretty non-obvious design conclusion that we came to. So only and skip do, as you may have used in other frameworks, basically they filter out which tests you're going to run. So if you call test.only and pass in your tests, only that test will get run. Every other test in your entire world of tests will get skipped. Skip is sort of the inverse. You say, I want to skip just this test, run everything else, but skip this one. And you can combine them in various ways to basically narrow down and get these subsets of your tests. The really important design decision, though, was basically trying to avoid the scenario where you accidentally turn off your entire test suite. So in other words, where you accidentally check one of these test.only things. Now this is sort of a lesson learned the hard way from working on code bases where you have things like it and then exit, which sort of basically let you turn off just one of your tests. And what I've observed is that basically what happens is you end up checking these in. Like you end up saying, I want to disable this test temporarily for this test run, but I'll end up checking it in. Or maybe you're not thinking in terms of the current test run, you're just like, this is broken for right now, but we'll get back to it later. And so you just do that. What I think is actually better if you're going to get back to it later is to comment it out. Like I think it's actually better to comment it out than to use one of these features. And here's why. When you have code that's commented out, it very obviously looks like a mistake. It's like, oh, this is debt. This is something I messed up. Like, you feel like you should delete it, and then you're like, wait, I don't want to delete this. This is a test. This is actually valuable. So I think having that sort of guilt and social pressure to not leave it commented out is actually a feature. And so I pushed for this. I said, I don't want to do this unless we can come up with some way to prevent people from accidentally checking these in. Like, test.only and test.skip should never get checked in. And the solution we came up with was basically, yeah, you can use these features, but if your tests pass, you still get a failing build. Like, if all of your tests pass, instead of saying tests pass, it now says test run incomplete. So it said there were no failures, so it'll tell you everything passed, but your test run is still incomplete because you use test.only or because you use test.skip. So now the next thing you have to do is go through and delete that, take that out, run actually all the tests, and then I'll tell you if your whole test suite passed or not. The first time I was implementing this, I kid you not, I accidentally checked in a test.only, and then CI failed because I checked in. I was like, oh, okay, good. I'm happy with this decision because I accidentally essentially commented out almost all of the entire test suite and checked it in. And then the last piece was CLI arguments for running specific files. So this is something that pretty much all CLIs have, where you say, like, I want to say elm-test, and then just give it a particular set of files, and it'll just run those files. This turns out to be pretty tricky, believe it or not. Running specific files is maybe easier if you're running them without having to do all this compilation and stuff ahead of time. But the problem was basically this. The way that we were running elm-test is we would say, okay, you have this main file that you write this file called main, and inside of it you accumulate all of your tests. You do imports to bring all the tests in from all of your different test files, and then we have a little port called emit, which sort of sends out to node, like a node worker, that then runs all the tests and then tells you what happens. Okay, so if we're running specific files, where does that main come from? Well, the answer is that basically we have to generate it. So we have to generate this main file, which is cool. That's totally fine. We can generate. We do generate it. We put it in the Elm stuff directory in the current release of elm-test. But then you get to this other problem with that solution, which is how do you decide what to put in there? So like previously, we would expose these tests and you would import them in main. But if we want to generate main by hand, how do we know which ones to import? So basically, I went on elm-dev and I was like, hey, I have this decision to make. I don't know how to resolve it. I mean, I was stuck. I was like, I can think of all these different trade-offs from all these different ways of doing it. And so I just wrote it out and posted it on elm-dev, the mailing list, and just said, what do people think? And just got lots of input from the community. People made suggestions, they made comments, talked about different solutions, and ended up with this design where the answer was it would just go through and look for all of the exposed values of type test and just glom all those together and generate these main files. So this worked, but there was a problem with the solution, which is that that's really slow. If you want to go through and like parse all of these in Node.js by hand, parse every single Elm file, and then try to be like, oh, which values are exposed of type test? That'll be easy to do just using string parsing, right? Actually, it's not possible using string parsing, because what if you didn't happen to write a type annotation for your tests? Oh boy. So the answer turned out to be, this was another case where I lacked domain knowledge, but I knew somebody else, my coworker Stoffel, who was not here at this conference, which is the first, and basically he fixed everything. And the way that he did it was by going into the Elm compiler and taking the part that just comes out and reads .elmi files, which are sort of these interface files that contain all that type information about a module, goes through and parses those and then spits out some JSON describing whatever it found. So this in turn let me go into the node test runner and run that binary, which we had to automatically download whenever elm-test installs, which is a whole other thing, and basically say, okay, cool, now I understand which values of type test are exposed from these modules, which means I can now generate the main for you, which means that finally you can run specific files. So Elm interface to JSON is the library that he made to do this. This is a separate standalone project, so if you want, you can use this for potentially some other purpose. I don't know what that other purpose might be, but at any rate, it's out there, and it's thanks to him that we're able to have this feature. Okay, finally, some long-term goals for elm-test. One of them is parallel tests, as previously discussed. Another is WebDriver tests. So although I think it's really useful to be able to run these much faster tests that are just testing the view and just testing update, things like that, I also think that it is important to be able to test actually in the browser. There are some things that you just cannot possibly test without spinning up an actual browser, even if it's a headless one. Golden tests, such as basically snapshot tests like Jest has. This is basically the idea of running a test and generating the output and then saying, this output is good, it's golden. This is approved output. And I want to rerun these tests later and compare what happens on these new test runs to what happened previously. So you have to have persistence from your tests. And then you can thumbs up or thumbs down and say, oh, these are different. Like if they're the same, then you're good, test passes. If they're different, then you actually have to have some interaction where the person running the test says, okay, these are different, but actually the new version's good. Or these are different and we found a bug. So I need to go actually fix my code such that when I rerun it, they'll match. So that's something we want to do. And then actually we want to combine those previous two things and introduce layout regression tests. So this is basically per pixel screenshot diffs. So this is, as far as I can tell, the only possible way to test for layout regressions is to basically run your tests using WebDriver to run them in an actual browser, take screenshots at certain points, save those screenshots, and then later rerun the tests and say, okay, if that screenshot doesn't match what we had before, give me an error. Like, tell me what changed. Now, I've read blog posts of companies doing this or teams doing this, and inevitably they seem to go the same way, where somebody's like, this took a ton of work to set up. It took a lot of effort. It's really cool, though. Check it out. Here's how we did it. And then basically almost nobody else does it, or very few people do it. So I think this is another good example of friction leading people not to write tests that would be really useful. As previously discussed with elm-css, CSS is hard to maintain, and layout regressions are some of the most nasty things you can possibly have to deal with. Like, elm-tss can solve the problem of what happens if you delete something, finding out if you deleted it and it was still in use somewhere. But it can't help you with, I want to refactor this. I think I've got an equivalent layout if I refactor these styles to be the same way. But it can't help you with answering the question, did I break any of my layouts on other pages? I know this page looks good again. I can verify that manually. What about the other pages? And ideally, we can take this to the ultimate extreme and, in fact, combine all of these at once and actually do layout regression tests running on WebDriver using the golden test idea, running in parallel on multiple browsers. So ambitious goals, to say the least. To sum up, so lessons learned from building elm-css. So first is using debug.crash to prototype APIs. Good idea. Maybe not for premature optimization, but for prototyping APIs, very useful. Don't sweat the syntax too much. Like, it's very easy to look at that and get really wrapped up in the syntax of like the DSL. But at the end of the day, that's not as important. It's just, it's a factor, but it's a smaller factor than other things, other considerations such as type signatures, documentation, and of course, the user experience of resolving errors. Also worth keeping in mind that part of the user experience of resolving errors is how intuitive people find the DSL, which could be based on other experiences they've had. So in the case of Decode Pipeline and in the case of elm-css, this is a case where, yeah, type signatures are important, documentation is important, but even if the error messages aren't ideal, people can often still figure things out as long as the API that you've set up is intuitive enough. Elm-test, lessons learned from that. One is researching and learning from existing designs is really important. The fact that we've been able to iterate on the previous designs of elm-test and elm-check really let the elm-test 2.0 design be a lot better. But it's important that we actually thought about those things and didn't just say, well, they did it this way, so we're going to do it this way. Or they did it this way, we're going to ignore what they did and just totally come up with something new from scratch. Just thinking about these experiences, learning, researching what's out there, quick check, other ways that people are doing things, jest, and learning from those is really important. Invariants are harder to introduce later, right? So having these invariants that are going to let us do parallelization longer term are going to be really helpful to us right now. One of the decisions that we didn't end up going with was sort of omitting that anonymous function wrapper in unit tests. If we hadn't gone with that, then someday when we want to introduce parallelization, we'd have to say, hey, everybody, you have to go through and add this anonymous function to every single one of your unit tests. It'd be really annoying. Or we might actually have to go through and tell people, hey, sorry, fuzz.andden is going away because it turns out to be a giant foot gun. Much harder to take those things away than it is to just not add them in the first place or to maintain the invariants early on. Collaborators bring domain expertise. Like, they can bring design, they can bring code, they can also just bring knowledge that you don't have. Or like in my case, there's a lot of knowledge that I don't have. It's important to reach out to them and talk to them. And finally, benchmark first, then optimize. Thanks very much.